In a few minutes, our research scholar, Eric Perrins, will explain how this question came to us and the very successful process he and his co-collaborators at Columbia University and Johns Hopkins put in place to examine it so comprehensively. But right now, what I'd like to do is take just a couple of minutes to place this project within the context of what we do at the Hastings Center. Since our founding in 1969, Hastings scholars have recognized that new biomedical knowledge and the technologies they spawn bring us new powers. These are awesome powers that have been incredibly inspiring, that allow us to push back on disease and to increase longevity. But no biomedical technology is neutral. Whether it be life-sustaining technologies like ventilators or dialysis machines that extend life, or synthetic biology and forms of genetic engineering that create new forms of life, or assisted reproduction, or the many technologies that are and will be emerging from neuroscience. In each case, we human beings should decide, I was going to say have decided, should decide whether to develop these tools in the first place, and when we do, we have to decide how best to use them. We have to determine whose interests will be served, whether any benefits will be shared fairly. And here at the Hastings Center, we also ask other questions beyond safety and fairness that are much more ephemeral questions, more profound, and very hard to answer. Like, what's the potential impact these new tools might have on critical ways of being in the world? On, for example, the parent-child bond, as we gain more and more genetic control over the kinds of children that we can create. And also profound questions about the possible impact of the broad use of these technologies on human relationships and on virtues that we care about, like respect and acceptance, or ambition or aspiration, or mastery and curiosity and agency. When Eric first conveyed to me his interest in pursuing this project, we both felt that it was socially very significant and ethically very controversial, and therefore right in the wheelhouse of the Hastings Center. The study of human intelligence is controversial in part because assumptions about genetic differences in intellectual capacity have been central in the most abusive eugenics policies of the early, mid, and 20th century. We like to point to the Nazis as the prime example of eugenics policy, and they certainly perfected their policies and implemented them on a scale not replicated anywhere else. But in fact, there was a robust worldwide eugenics movement which began in the late 1800s and took off in the halls of and spearheaded by leading academic institutions, including Yale and Princeton and other places that carried great prestige and carried these ideas forward with great prestige. Ideas that were then further carried forward by state legislatures. In 1907, Indiana was the first state to pass an involuntary sterilization law, which stayed on the books and was used to sterilize hundreds, if not thousands, of incarcerated men and institutionalized women right up until the 1970s. So from 1907 to 1974, more than 30 US states followed Indiana and passed these laws, as did a dozen countries. So the Nazis were emulating the scholarship and health policies they saw in the United States, Great Britain, and other countries. Policies like involuntary sterilization were based on the idea that we need to enhance the human gene pool. Now, our tools, of course, were more limited then than they are now, and the best way that was perceived at the time was to encourage procreation among those with high intelligence and to impede it among those who were perceived to be less intelligent, and moreover, they thought they could tell the difference. And the language of the time was that they were identifying the feeble-minded. So fast forward to 2013, human genetics research has accelerated beyond our wildest 20th century dreams. Genetic researchers want to predict want to identify the genetic predictors of human intelligence, and they are undertaking these studies. But should such research proceed? Is there a way to balance our commitments to free and open scientific discovery, our human drive to understand and to learn, no matter where it takes us, something most of us in this room would encourage? Is there a way to balance that kind of discovery? Or are there limits that we should place, or at least steps we can take to ensure that we do not repeat historical errors? That's the paradigmatic kind of dilemma or question that we take up at the Hastings Center. Many of our projects take on hugely significant, unsettled questions with enormous societal implications, questions where reasonable people will disagree. We purposely seek out those people, and we bring them together around the table in our library, in our beautiful facility in Garrison, New York, about an hour north of here. We've developed the skills to negotiate these difficult conversations, and we know how to help people listen to one another respectfully, even when they disagree. The result are new ideas, thoughtful insights that get expressed through special reports, through books, through scholarly papers, and increasingly through public symposia like this one. So with that background and placing this question in the context of today's question, I'm going to now turn things over to Eric Perrins. He's a senior research scholar at Hastings for the last 20 years, and Eric is also the author of Shaping Ourselves, which is a new volume that was recently published by Oxford University Press on enhancement technologies, and he co-edited the report that we're here to talk about with his colleague and our friend of the center, Dr. Paul Applebaum, whom Eric will introduce in a moment.
Great. Thank you, Zoe. The plan is pretty simple. Millie just introduced me. You know all you need to know about me. I will speak for 15 minutes. Then James Tabery, who is a philosopher at the University of Utah, who teaches not only in the philosophy department, but in medical school as well, and who is the author of Beyond Versus. Wonderful title. Beyond Versus, the struggle to understand the intersection of nature and nurture. After I introduce some of the very most basic scientific ideas at stake here, Jim will talk a little more in depth about the history of scientific investigation of intelligence as well as the ethical debates surrounding them. Then Dorothy Roberts will speak for not longer than 15 minutes as well. Dorothy has a joint appointment in the law school and in the sociology department at Penn. She's the director of the program on race, science, and society, and most recently is at Penn, and is most recently the author of Fatal Invention: How Science, Politics, and Big Business Recreate Race in the 21st Century. Dorothy will then speak to some of the ethical concerns about contemporary research into eugenics and intelligence. And finally, Paul Applebaum will speak. Paul, well known to many of you, is the director of the Division of Law, Ethics, and Psychiatry at Columbia, and is also the director of Columbia's Center for Research on Ethical, Legal, and Social Implications in Psychiatric, Neurologic, and Behavioral Genetics at Columbia. Among other things, he's the father of the idea of therapeutic misconception. If you've ever used the phrase therapeutic misconception, this is the guy who's the author of it. If you've ever read the book on informed consent, he's the co-author of it, and on and on. Paul will then summarize the conclusions that our work group reached. But what I want to do first is step way back and to begin to try to get us a sense of the scientific landscape. When I was growing up in the 1960s and 70s, there were many educated observers who were quite confident that environmental factors could explain why there is variation in any population with regard to a huge number of traits. Environmental factors could explain why we are different with regard to how much we want to eat, how much we tend to drink, in how sunny or gloomy our personalities are, and in things like how well we score on IQ tests. You pick a complex trait, and we have an environmental explanation or a factor that could explain it. Now, to remind you, who are those of you, and to inform those of you who were not even born in the 50s and 60s and 70s, there were some pretty bold claims made at the time. There were, to pick the most egregious examples, one of the ideas floating was that a single factor, like say how one was toilet trained, could determine one's personality. It could determine whether one was obsessive or anal retentive, as the term went. Equally thoughtful people had a single theory about why it was that some people became autistic and others didn't, and why some people became schizophrenic and others didn't. And the idea was there was style of parenting. In particular, it was refrigerator mothers that were producing children with schizophrenia or children who had autism. So today, nobody buys such mono-causal environmental explanations, right? Which, by the way, should not mean that we no longer think environments are important. It means we don't buy mono-causal environmental stories of the kind that we were telling then. Okay, so in the 1970s and 80s, there was a pendulum swing, or if you prefer, we began to use a very different lens. A different lens became popular among folks that formerly were enthralled with the earlier kind of monocausal explanation. Educated observers became confident that genetic factors could explain all of those same traits, from how heavy people were to how they scored on IQ tests. One of the cornerstones of the new confidence was twin studies, which were done by people who call themselves behavioral geneticists. To undertake one of the experiments that led to this new idea about the significance of genes, one has to do a very, very simple sort of inquiry. First, behavioral geneticists make two assumptions. The first assumption is that identical twins share the same environment. And fraternal twins share an equally similar environment, right? If they're in the same home. The idea is the environments to which identical twins and to which fraternal twins are exposed are going to be equally similar. Assumption one. Assumption two, whereas by definition identical twins are 100% genetically identical, fraternal twins are on average 50% genetically identical. Okay, got two assumptions in place. You pick a trait that you're interested in. If it's height or weight or what's measured by IQ tests, whatever, depression, autism, whatever it is, you pick a trait and you go out into the universe, out into the world, and you start collecting sets of identical twins and fraternal twins. The more similar that identical twins appear to be with regard to a trait, the more highly correlated, and the less highly correlated the fraternal twins appear to be on the same trait, the more reason behavioral geneticists have to believe that genetic differences are helping to explain the observed difference. So, so, as it turns out, if you go out into the world and you do those kinds of twin experiments, you find that genetic differences help to explain variation with regard to all of the traits that we've been talking about so far. This is true about everything from weight to emotional intelligence and to general intelligence. So we're finally getting to what behavioral geneticists mean by general intelligence. They mean something like the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. Essentially, what they think they're measuring is the ability to solve problems quickly. That's the core of it. Now, you might say, well, I don't think that's a very important skill. It's not as important as emotional intelligence or interpersonal intelligence. You might be absolutely right about that. That's not what they're arguing though, right? They're interested in this particular capacity.
Sorry, I seem to have lost my internet.
Of the traits that psychologists study, general intelligence is actually more valid and reliable than the other traits they study. Now, do we wish it were more valid, the construct? Yes. But again, in the real world, if you're trying to help real people, your constructs are going to be full of problems. Just like if you want to study extroversion or introversion or agreeableness or all that, you're going to have all sorts of problems with validity. But the point is that when behavioral geneticists say they're interested in studying genetics, at least they can tell you what it is how they're going to measure, what it is and how they're going to measure it. And if you take a behavioral geneticist in another country, she can reach the same conclusion regarding the set of traits that the behavioral geneticist is interested in. Okay, now, it's really, really important to take on board the following fact. Twin studies can show us that genetic differences are making a difference with regard to why people are different, right? We've inferred that those fraternal twins are more different than the identical twins. The reason has to have something to do with genetics. Twin studies, however, they can tell us that genetic differences make a difference. They cannot tell us anything at all about which genetic differences are making a difference. They can't tell us anything about which genetic variants are making a difference or how they're making a difference, right? It was in the 1980s and 90s when behavioral geneticists went from using the emerging tools of molecular genetics to try to determine which genetic variants were making these observed differences. So they went from using twins to trying to use DNA. Now, you will remember, perhaps, some of you who were born then, and yes, Brian, I appreciate some of us were not. Some of you will remember that in the 90s and 2000s, there began to emerge stories about genes for medical conditions like rare diseases, Huntington's and CF. I'm sorry that I misspoke. I meant to say that in the 80s and 90s, it was medical geneticists who were beginning to make claims about single genes for rare disorders like CF and Huntington's, to name the most famous. It was 10, 20 years later when more and more behavioral geneticists made the leap from claims about single genes for rare disorders to claims about single genes for complex behaviors. So some of you will remember stories. I can show you, if I had the time, I would show you the story, the covers of Time magazine, the gene for aggression, the gene for depression, the gene for intelligence. By the way, I hope some of you in mind of the story I was telling you earlier about monocausal environmental explanations. Well, these monocausal genetic explanations met the same fate as the monocausal environmental explanations. They went absolutely nowhere. None of those findings of the gene for those complex behaviors ever was replicated. I hope this is a fact. It's an important fact. None of those genes, single genes for a complex disorder was replicated. So today, instead of hoping to find single gene variants that are with large effect sizes, for the most part, and there are lots of exceptions that we can certainly discuss, for the most part, a behavioral geneticist doesn't go out into the woods looking for a single gene with a gigantic effect. What she does is go out and hope to find many genetic variants that have a small effect. In the case of intelligence, the most successful study that has been done so far was able to identify 3 genetic variants, each of which could explain 0.02% of the variance between the control and the high IQ people they were interested in. I did not say 2%. You did not mishear me. I said 0.02% of the variance. Okay, we're talking about effect sizes that are almost impossible to detect. To detect them, you need gigantic sample sizes. I must say that for me, one of the most interesting things about our meeting was the coming together of behavioral geneticists with very different views about the future of this research. The optimists say, look, all we need to do is get bigger sample sizes and collect more and more variants associated with tiny effect sizes, and we'll finally add them all up, and then we'll have a big effect size. And you all ought to hope that's right in some ways, because all precision medicine is in some ways based on this idea, okay? Your taxpayers, a lot of money's going to this, okay? One of our behavioral geneticists, Eric Turkheimer, actually was calling into question what he refers to as the additivity hypothesis, the idea that if you just add up enough small effect sizes, you're going to get a big effect. Well, anyway, people who are committed to the idea of the additivity hypothesis, people who accept the additivity hypothesis, understand, as I just said, that to start picking up small effect sizes, they have to get ever larger sample sizes. The only way you can pick up a small effect size is if you have a huge sample size. And we're talking hundreds and hundreds of thousands of samples in order to get the kinds of effect sizes that these guys are looking for. I'm finally I'm almost there. 2 researchers who very much accept the additivity hypothesis and are deeply committed to understanding the genetics of intelligence in this way, went to the Center for Talented Youth at Johns Hopkins University. It's a program, I know many of you are familiar with it. It's for children who are especially gifted, and the whole purpose of the organization is to help gifted children exploit all of their gifts. The researchers, I should mention, not only said they're interested in basic research. I think the genetics of intelligence, however it plays out, genes are really important, and it's a really interesting basic question. I think there's no doubt about that. But they were arguing that in addition to pursuing this very interesting scientific question, they also envisioned that someday it would be possible to tailor educational interventions to genomes, much the way precision medicine folks are envisioning tailoring medical interventions to genomes. So what happened was these researchers came to these very thoughtful leaders at the Center for Talented Youth and said, should we give these researchers access to our alumni, right? The researchers want to study their alumni. And so the researchers, being the CTY leadership, they had some really thoughtful people, immediately took there to be a dilemma. On the one hand, they believe in basic research, they do it themselves, they're deeply committed to helping their students like their children do as well as possible, on the one hand. On the other hand, they know all about that history that Millie was talking about, and they have all sorts of concerns about what might happen in the future. Long story short, they sent, CTY saw the dilemma, they didn't know what to do. They went to Gail Geller at Johns Hopkins. Gail said, oh, you ought to go to Eric and the Hastings Center because they've been thinking about this kind of stuff in the past. And I went to Paul, and so Columbia's the seer, Hastings Center, Hopkins, we all decided to have a workshop. We brought together 20 people, all with very, very different views. I mean, I already told you that within the science there were deep disagreements, right? So you can imagine how many disagreements there were between people who study science, and so we had educational psychologists and so forth. Anyway, we had a workshop and tried to grapple, and we did grapple with this question: how should a group like CTY think about this request to get access to students? How should reasonable people think about this sort of research and whether or not to participate in it or try to get in the way of it, etc. So we held the workshop. We turned it into a special supplement, which you all can get a free copy of. The purpose for the remainder of the talks is for, you're going to get 3 wonderful examples of speakers we had at the meeting. And we can't do it all. We can't reproduce the workshop for you, but you're going to get a nice taste of some of the issues that we faced, and then ultimately Paul's going to tell us about what was concluded. So without further ado, Jim.